Well, on that happy note, it's now time to introduce Mr. Samir Shelke. Well, he'll be delving into the topic of automating cybersecurity for the fintech sector. Well, the co-founder and chief executive officer of Aujas Cybersecurity, he has more than 3 decades of experience in cybersecurity and, of course, information technology. Well, he is an active member of the Forbes Technology Council, ladies and gentlemen. Well, Samir has also held several technology and business leadership positions and leads the high performing teams to conceptualize, to manage, to implement complex, very complex security services and solutions. It's time that I give the virtual microphone to Mr. Samir Shelke.
Hello, everyone. Thanks for joining today. I'm going to talk about cybersecurity automation in this session. And while this is a topic which is top of the mind for all of us in cybersecurity and controls, what I want to focus on this discussion is the implementation aspects of cybersecurity automation. So, as I said, it is something which is top of the mind for everyone. It is what we call as writing on the wall. We hear amazing technologies come to light, be it security orchestration, automation response, threat intelligence, use of machine learning, artificial intelligence, robotics, and all of it are great technologies which are currently being used, some mature, some maturing, in the way cybersecurity is handled today. It's definitely something which we are seeing coming up in a big way. It is something which we will see being implemented in the marketplace in our organizations on an ongoing basis. So that's a given. It's something which we are seeing. Now, what I really want to focus on is, and that's what Aujas does as engineers of cybersecurity transformation, is how to make it work in our customer locations and environments, right? So that's essentially the focus of this conversation. Before we get into that, let's talk about why is automation such a big thing in cybersecurity? Because the benefits of automation are extremely important for us to understand in the cybersecurity world. So let's talk about basic 5 elements why automation is of great use in cybersecurity. The first one being accuracy. Now, humans are the weakest and the strongest link in security. We all know that for years. Now, mistakes or what we call human errors is one of the biggest challenge we all face when we implement controls and manage controls. And hence, if machines are able to accurately do repetitive tasks, that's a big achievement for us. And hence, accuracy is definitely one of the areas of improvements or benefits of automation. So that's one. The second obvious one is speed. Especially for predictable tasks, for analytical tasks, for automated tasks, the speed at which machines can operate in an efficient fashion is definitely key as a benefit, and that's the reason why it is number 2, of course. The third thing being scale. One of the biggest challenges we have is amount of data security tools and controls generate, and hence the amount of noise which is there for us to find out what is really important for us. So that scale of operation is something machines and automation can really achieve in a very good way for us and decipher information which can then be used by humans for decision-making tasks. So scale is the third important thing, of course. The fourth thing being consistency. One of the challenges we have as we manage controls and do risk protection measures is to be consistent all the time. I mean, the bad guys have to get it right only once, while we have to get it right all the time. And hence, consistency of response, consistency of what we do is extremely important. And which is why, again, machines can be a great tool for us to do that work. And automation in consistency would be a big advantage for us. And the final, possibly the most important one from a human perspective is being skill efficient. Now, we all know that security skills are the biggest shortage all over. and hence using the skills which are available to do the right things, which are important, which needs creative thinking, out of the box thinking, needs that specialization is very important. And hence using machines for things which can be done by them and leaving us time and energy and skills to do what we can do better is what I call a skill efficiency. So these 5 things really, which is accuracy, speed, scale, consistency, and skill efficiency, are the big reasons why cybersecurity automation is the top of the mind and the trending topic today. So the question comes up, right, is if that's the case, why is that it is not mainstream as yet? And it definitely is not to do with availability of technology. We talked about in the previous slide about some great technologies being available, from SOAR to BAS to threat intelligent feeds and stuff like that. So all of them are great technologies. What possibly is missing is how to make it work in our environments. And that's where the next point of what we call as human factors come into play. Human factors is a larger topic which deals with basically how humans deal with processes and machines and tools. And that's a larger subject, of course, but in context of this conversation, I'm looking at that one topic as to how do humans and machines interact? And that human factor is important for us to understand. It is important to understand so that we can use that to make implementation choices so automation can work for us. And that's essentially what I'm trying to discuss here. So first of all, I think if you look at machines and look at humans in a very simplistic form, what is that we are good at? So machines are definitely good at repetitive defined tasks. Machines are really good at complex computations, and machines are really good at multitasking. By definition, that means that those are also the 3 things humans are not as good at. I mean, we do believe we can multitask well and so on and so forth, but the fact is, for us to compartmentalize and do things in an efficient, consistent form is always time dependent or situation dependent. But if you look at a machine, it can be repetitive, it can be very consistent, it can do complex tasks, and it can multitask. So that's clearly an advantage where machines are better. You look at the human aspect in human factors, what humans are better are adapting to the unknowns. And that's essentially is where we know the context better, we can relate to the context, we can have experiences which we can use, and hence adapting and course correction to handle unknowns is something humans possess, which machines don't. The second thing is about creative thinking, finding ways to do the same things better given the specific context and the specific environment. Creative thinking out of the box is something humans do extremely well. And the third most important thing possibly is relationships. Now, of course, machines can make it pleasant to interact, can give enough data to interact, but when it comes to building relationships, machines definitely can never match up to what a human can do, right? So building relationship, creating those connects is something humans are really great at. So if you look at human factors as to the relationship between humans and machines, and these things is very important for us to understand as we look at implementation of automation technologies in real world as far as cybersecurity is concerned. So that's the essence of what we do as a company. When you look at our automation methodologies, we look at how we automate cybersecurity for our customers through our cyber defense centers. We look at technologies, we look at amazing technologies which are available and make them work using human factor models. We call that human-centric automation. And to explain this point, I want to take 2 examples of automation as to how one can automate specific functions. 2 very, very simple examples. The first one is security operations. Now, this is obviously the whole area of incident analysis, incident response, SIEM operations, and whole gamut of things, which we all do on an ongoing basis. If you look at security operations, and at a simplistic level, if you plot as to how a security operations specialist, for example, spends his or her time, you would see something typical like this. And I'm calling it relative time because I'm going to relate it to the other example I'm going to give. So if you look at the time spent, obviously there is time which is spent on data collection and processing. So obviously data coming from security feeds, data coming from tools and devices and SIEMs and stuff like that. The data is obtained, the data is processed, and then the operator then applies expertise on top of it. Once that is done, then the operator defines or executes defined runbooks and processes to do his or her job. If you look at that's typically the time which is being spent, and it's clearly, we know this, that in security operations, you do a lot of more repetitive tasks, you do a lot focused on processes. That is possibly the largest area we spend time on. There's obviously an element of research, which is, research is not finding something new, but looking at what can be applied in that specific situation, looking at other examples and things like that. Then there is, of course, an element of stakeholder interaction when it comes to talking to different functions, resolver groups management, and so on and so forth. There's obviously a function of reporting. And there's also a function of team collaboration. Now, when I say team, it could be folks in other shifts, it could be folks from other security towers, and so on and so forth, because security operations is a fairly collaborative job, so to say. So if you look at the percentages here, this is the relative time spent in these areas. Obviously, all of them totaled up to 200 from a relative perspective, right? So that's how time is spent on security operations. Now, let's look at an element called automation index, which is, on a scale of 1 to 5, 5 being it can be automated the most, and 1 being the automated the least. If you look at that kind of a scale, one can plot an element like this, where one would say that when it comes to data collection, that can be automated really well, because we have the technologies available. It is very deterministic on where the alerts are going to come from, so that can definitely be automated. We can also process the automation side of things, because those algorithms which can be built are built already, where it can be processed. Applying expertise, this is typically the area of a human playing a lot more role, a little more role. Of course, this is improving as well as we have orchestration technologies, etc., coming into play, but humans play a little more role in that area. Again, when it comes to process following, again, can be automated in an extremely good way. Contextual research is not as well automated. Likewise, when it comes to reporting, yes, it can be automated. When it comes to stakeholder interactions, not as much. Team collaboration, again, is a function of how human relationships and how we really work with them. So if you look at the level of or degree of automation as an automation index in all those functions, you can see what can be automated. And that's where you take an automation technology, take a process, and use human factors to determine what is the level of automation possible, and look at what I'm calling as a cumulative automation index. Let's say on a scale of 1 to 5, security operations falls in a 3.25 kind of a range. This is one example of applying human factors and on a typical cybersecurity function. Now let's take another example in our world, which is on application security validation. Now, this is the whole area of penetration testing, code reviews, and what have you. Now, if you take that as an example, again, from relative time spent of similar tasks, there is obviously a notion of data collection, which is identifying of the assets we want to test and the targets, so to say, we want to test. There's also an element of processing, which is understanding the landscape of what are the available targets you want to go after, and so on and so forth. But you notice here that, and you would agree with me, that application of expertise is far higher in this space, where we need to understand the threat models, we need to understand the threat vectors, and we need to understand where the ingress and the outgress points are, and where the vulnerabilities lie, and so on and so forth. Obviously, there are tools and techniques available for this as well, but here the human expertise is applied a lot more, and the time spent is a lot more as well. Of course, there is process adherence, but not as much as compared to, let's say, a security operations area. Another area where there's a lot more time spent is on research, because again, contextual application of knowledge with the current environment, the current, let's say, for the application code, the vulnerabilities, etc., is very, very contextual, and hence that research element has to come in there. A big difference you see here is on stakeholder interaction as opposed to reporting, because here the tester essentially interacts with application development teams and makes them understand what the findings are, what the remediation mechanisms are, and so on and so forth. So that's a big area of focus here. Not as much on team collaboration because it's generally a fairly contained kind of an environment. There are no shifts, etc. typically gets involved. So if you look at the relative time spent on a function like that and then plot the automation index again on a scale of 1 to 5, we would see that it's a little different. There is obviously data collection can be automated to a fair degree, but when it comes to applying expertise, it is not as much. Now, of course, there are breach attack simulation tools and testing tools and so on and so forth. But when it comes to complex algorithms and it comes to complex code, it's not really there yet. The expertise really come into play in that area. Likewise, yes, processes can be automated. Reporting, it definitely can be automated, but it comes to contextual research, when it comes to stakeholder interaction, specifically with the application development organizations, that is relationship based here. So that cannot really be automated. So if you look at how the automation index plays in a function like this, it is slightly different. And obviously the level of automation possible in a function like that in relative terms is much lower. So the whole point here being that their automation is here. I mean, and especially in cybersecurity, for the areas we spoke about in terms of the benefits it gives us, it's a given. It's something we're going to see in a large scale way going forward for sure. Technologies are evolving excellently well. And there are brilliant technologies available, algorithms available, technologies which use machine learning, AI, ML kind of stuff, and they are being practically deployed. So availability of technology will only get better. I think we as practitioners have to find ways of how in our organization, the human factors of how we work and how these technologies work, how do they play and coexist. And this example of really talking about each function and what can be automated, looking at a cumulative automation index is extremely important for this whole area to succeed and for us to be better risk managers. We at Aujas, we call ourselves engineers of cybersecurity transformation. Our job essentially is to make these amazing technologies work for our customers and really give benefits what they have to provide. So, that's what we do as a business. That is how we have built our cyber defense center across various domains of cybersecurity. Our delivery engines are including automation as part of what we do. And a big focus of that is on using human factors in addition to amazing technology being available so they can best serve the interests of our customers. So that's all I had to say. I hope you found it useful. Thanks for joining again. Bye-bye.
Thank you very much, Mr. Samir Shelke. This session was indeed very thought-provoking, and I absolutely mean that.